here. There's this concept when we're solving quadratic equations. Oh, I'm going to check if there is a comment. Is it a comment? No, it's more people joining. There's this weird thing. So we're going to start off with this. If I have A times B equals 0, which of those two letters is actually equal to 0? And the thing is that if you get any number or any letter and you multiply it by 0, you can get 0. So there's actually two things that could happen. The A could be equal to 0, or the B could be equal to 0. Right? So this concept is quite important when we're solving quadratic equations, because when we're solving them, there's actually going to be two solutions a lot of the time, right? Because here, A times B equals 0, A could be 0 or B could be 0. That's the concept. So we're going to have a look at, let's have a look at question. You guys, what are you doing? You're doing only even questions, right? Let me double check that because I don't want to step on your toes. Yep, only do even questions so I can do odd ones. So we'll start with number 1 in exercise 17.01. And it says that x plus 2 and multiplied by x plus 3 equals 0. So we're going to use that concept that we looked at, and we're going to split it off because either of these two brackets could be equal to 0. So what we do is, or what I do, is I draw a little arrow down here, and I say x plus 2 could be equal to 0, or over here, x plus 3 could be equal to 0. So there's two possible scenarios here. So we can pretty much just split it off into two linear equations. And then I'm just going to solve over here. So to solve for this one, I'm just going to go minus 2 on that side, minus 2 on this side. So then these cancel out, and you get x equals negative 2. And then over here, I'm going to minus 3 on this side and minus 3 on that side. And these cancel, and we get x equals negative 3. There's something else that people like to do here, and they like to label their x's. So there's actually two solutions. X could either be equal to negative 2 in this scenario, or x could be equal to negative 3 in this scenario. So I actually like to label it so that my smaller of the two values is x1 and the larger of the two values is x2. So which is smaller out of negative 3 and negative 2? I'm going to see if you guys are actually awake. Which is smaller out of negative 3 or negative 2? You guys, and I can use this to check. In the chat comments, guys, I'm going to see if you're awake. Oh, wow. Well done, Brownie. You're absolutely correct. Negative 3 is smaller, so I'm going to call that one x1. And then negative 2 is larger, so I'm going to call that x2. Because there are two solutions. I'm sure that you guys already know that. Yes, you're right, Petra, or Petra, however you pronounce that. Okay. So let's see if we can find a harder question. This question is not harder, but it's unique. So we're going to have a look at question 9 quickly. Now, question 9 is 2x 4 plus x equals 0. So it looks a little bit different than the last scenario, but really it's probably easier, if anything. So again, this is being multiplied by that. So either of these two things being multiplied could be equal to 0. So let's split it up again. So over here, we could have 2x equals 0. And then we'll split off this one. And that could be 4 plus x equals 0. So 2x equals 0. 2 times x. How do we unpack that? I'm going to divide this side by 2. 0 divided by 2. Oh, easy. X equals 0. And over here, I'm going to minus 4 on that side, minus 4 on this side, and we get x equals negative 4. Which one's smaller? It looks like negative 4 smaller, so I'm going to call that x1, and I'll call that x2. All right, not too hard. What's another question that might be a little bit harder? This one looks like it's scary as question 29, so we'll have a look at that one. Again, it's an odd question, so you guys don't have to do that, so I can therefore steal it away from you. So 29, let's have a look at this. So it's ax plus b in brackets, and then multiplied by cx plus d equals 0. Let's see how hard this is. So we split it up. Ax plus b equals 0. What's going to be hard about this one is remembering what it is that you're trying to make the subject. See x plus d, because you guys see letters and you maybe get a little bit scared because you see letters. But remember, x is the variable that we're trying to solve for, and a and b are just constants. So we've got to unpack this in order using SAMDEB. There's addition, so we've got to minus a b off both sides. So we get ax equals negative b. And then we've got to divide by a to get rid of that a with the x. So we get x equals negative b over a. Oh, my hand got a little bit shaky there. That's an ugly b. Looks like tilde b. Okay. And on this side, we have plus d, so we're going to minus d on both sides. So we get cx equals negative d. And then we need to get rid of that c, so we're going to divide by c, x equals negative d over c. Which one of them do you guys reckon is smaller than the other? I have no idea, so I'm not even going to label which one's x1 and x2. Don't worry, you guys don't need to do that either. I'm just going to check if you guys have any questions. If you have any questions, if I'm going too fast, can you please do question 35? I certainly can do 35 because it's an odd number. Should I skip? Yeah, let's do it. Okay. Question 35. Yeah, so questions 31 to 36 are like reverse engineering. I don't want to waste paper, so I'm just going to draw a line up here. So yeah, I'm happy to do question 35 for you. If you guys want to request any odd question, I am happy to do that. So yeah, pick one that is useful to you guys. That's fine. So we've got x equals negative 1 over 2, and we've got x equals 3 over 4. So all I'm going to do is I'm going to reverse engineer what I was doing for the other section, right? So I'm going to do the opposite of unpacking an x, and I'm going to repack the x. So here I can see that I've got to divide by 2. So I'm going to times both sides by 2. So then I get 2x equals negative 1. And I'm going to keep packing it up until I'm left with an equals 0. So I'm going to need to add 1 to that side and add 1 to this side. So I'm going to get
Mister, we can't hear you. Hello?
The sound's off again.
Oh my god, I sound like a little boy. Mister!
Zachary, I think
Yeah, you are a little boy.
I'm like still in bed and I just woke up, so I have like the morning voice.
I am so tired.
Mister, can you wait?
He
If
can't
he
even
can't hear
hear
him,
us,
he
okay?
can hear us.
He can't hear us again.
Yeah, we'll do
Shout out
like
to
a
Jim
Someone
Cook.
spam it, someone
we'll
spam
do
it.
like a
We need
voice
to know
over
this,
for
but
him.
this is my bed. I
So,
access code.
so right now
Yeah,
he's
Kim,
running
Kim,
the
spam
street.
him.
We
June
have to
spamming
draw a
again.
line to divide everything.
Wait, what is he even talking about? I need to note this down.
He's
Oh god, wait.
just silent language. I need to learn this language.
Can you
I need
teach
to learn
the
this.
exponents? Can you teach the exponents?
Oh my god, Mister, what?
Those are the randomest things ever.
One
The
day.
exponents and then the
Mister, we can't hear you. Oh my god, this is... Okay.
This is bad.
he's still going.
This is really bad.
This is
Right.
from the
How
worst
is
one.
it? Is he
I'm gonna
disconnected or
smack
This is like the
him.
original one.
He doesn't even know what's going on.
Students, please keep your phones or microphones off. Thank you. Mr. Forbes, you cannot be heard.
Oh, do you guys want me to re-explain that verbally? Just give me a yes or a no. Okay, sorry.
Yes, please.
Dang it, this is the most important verbal explanation and my flippin' wireless headset cuts out. Oh well, okay, so let's have a look at this again. I'm gonna use my mouse, it's more fun. Okay, so over here, what I did was I got the two sides. So I had x equals -1/2 and I had x equals 3/4. And what I was doing was I was repacking them. I feel like I had such a good explanation as well. So what I'm doing to repack it is I'm trying to end up in a form where we've got x packed away equal to 0. So all I'm doing is doing the reverse of what I was doing before. So I've got -1/2. So I'm trying to repack the x. So I'm multiplying both sides by 2. And so see how x is getting in this more complicated state, but the right-hand side is getting closer and closer to being equal to 0. All right, so we got 2x equals -1. So I added 1 to both sides, and I ended up with this expression here that's equal to 0. All right, so 2x plus 1 equals 0. And once I had that, I was ready to put it in brackets, because the whole idea is each bracket needs to be equal to 0 so that you get this 0 as a result. Now, there is actually another way that you could do it, and I think there are infinite ways to pack it away, but this is definitely going to get us the cleanest looking factorization, or the cleanest looking quadratic equation. So over here, I was just repacking the x, multiply by 4 to get rid of that, and then -3 to get rid of that. And so I ended up with these two separate expressions that are equal to 0, and I just put them away in the brackets. And remember, all we're doing is we're just doing the reverse of what we were doing down here. All we're doing is the reverse. So it's like they've given us the answers, and we're trying to pack it back into the factorized form. All right, so here, let's pretend I was doing this one backwards. I'd have -d over c. I'm going to need to multiply both sides by c. Perfect. I'm going to need to add a d to both sides, and then I would get to this form, and then that's what can go into the bracket. I hope that's clear. I think I did a better job than I was actually doing it. If you guys want me to do another example, I can, but we probably need to move on. I think if you can see how 35 is done, that should mean that you're able to do those other questions. I'm going to quickly look in the comments. Do you need me to go over that? No, we don't have time. Okay, let's have a look at 17.02. Solve these quadratic equations by factorizing first. Now, she told you to do only the even questions, which is extremely convenient for you guys because they happen to be the smallest questions. That's the dream. Oh, is that a comment? How do we know? How do we know which equation is even or odd? Because yeah, this one here, it's hard to know what's even or odd. I would just do every second question. I think that's what she means. So let's pick an example from here. I'm sure you guys have done some sort of factorizing before, but there's no harm in revisiting a technique to do it. So let's look at question 1 first. So this is in 17.02. So question 1, what's a good example for us to look at? How about we look at k, just because there's a few options there. So we've got x squared plus 5x minus 24 equals 0. The most important thing about this is that it is already in quadratic form. And quadratic form is that ax squared, so all the x squareds are together, plus bx, all of the x's are together, plus c equals 0. This is quadratic form. And if it's in this form, that means it's ready to be factorized. Okay, so just a quick reminder on how I do this. This number here, I need to find two numbers that multiply to get that, and I need to find two numbers that add to get this one. What I do is I draw a little T underneath that, including the symbol. And I think of all of the ways to get -24 by multiplying. So I could do -12 times 2. I could do, what are some other options? 8 times 3. So I could do -8 times 3. I could do 1 times 24. That's an option. And you keep making a list, but we're actually aiming for a positive 5. So these add together to make negative 10? No. These add together to make negative 5. Ooh, that's a clue. If they make negative 5, I just flip them around and I'm going to get a positive 5. So I get a positive 3. Oh, no, sorry. A negative 3 and a positive 8. Those two added together get me a positive 5. So those are my numbers, negative 3 and positive 8. So we factorize by just opening two brackets, put it equal to 0. So this is the first one, x minus 3, and this is the second one, x plus 8. I'm going to quickly check the question, see what's going down. Nothing's going down. Nope. So what we do now is those little arrows, just like we were doing before, except this time we've got the added bonus of having to factorize first. So we get x minus 3 equals 0. Add 3 to both sides. X equals 3. On this side, we've got x plus 8 equals 0. And so we minus 8, and we get x equals negative 8. I'm going to call this one x1 because it's smaller, this one x2 because it's larger. But that is now factorized and solved. Okay, moving on. Question 2. Are there any difficult looking ones? To be honest, question 2 is all the same pattern. I feel like if I show you how to do that, you're going to be able to just do all of them with way too much ease. The interesting thing is they are in quadratic form, but look at this. Every time we've got a negative x squared. So the trick for these is just move everything to the other side or multiply everything by negative 1. I think I like the idea of moving everything to the other side. So I'm going to look at 2a. 40 minus 3x minus x squared equals 0. Oh, my equal sign's not going to be nicely balanced. Maybe I should do the negative 1. Okay, we'll multiply everything by negative 1. So we get negative 40 plus 3x plus x squared equals, what's 0 times negative 1? Oh, yes, 0. Okay, right. I think Europeans do a cool little thing over here, which I really like. They write times negative 1 like that. Oh, beautiful. Right. That's still not quite in quadratic form, so I'm just going to move things around a bit. I'm going to put that x squared at the front and then the minus 40 at the end. From there, we would factorize, but you guys already know how to do that, so you can do the rest. Can't hear. Yeah, there's got to be, I need to like give one of you guys my personal phone number so you can call me when my thing's cutting out. So annoying. Okay, question 3. Things are getting a little bit spicier, which is good. Let's have a look at one of the harder questions if we can find one. That one looks kind of cool. 3i. So we got 18x minus 24 x squared equals 0. First thing we should do is put it into quadratic form. I'm going to show you the trick that I wanted to show you last time, but I ran out of space on the page. I'm going to do this. I'm going to add 24x squared, and I'm going to minus 18x squared. I'm moving everything to the other side. So I get 0 equals 24x squared minus 18x. I like the idea of moving everything over. It's quite satisfying. Okay. This is in quadratic form now. What we actually have at the end is a plus 0. See how the last part of our quadratic form just doesn't exist for this equation. Okay, 24 and 18, I'm recognizing a pattern in my head, and I know that there is probably a better way to solve this, but I'm just going to show you a way that will work universally. 18 and 24 I recognize as numbers like this: 6, 12, 18, 24. That's counting up in 6s. All right, so I could divide everything by 6. So let's do that. We'll divide this by 6, divide this by 6, and then those are zeros, so we don't really need to worry about them. So we get 0 equals 24 divided by 6 is 4x squared, and then minus 3. And then we've still got that plus 0 on the end. I think there's something that they want us to do or want me to do that's cooler. Let me think about it. Nah, maybe there's not. Is there a better method for this? I feel like I'm missing something. Okay, 4x squared minus 3 plus 0. So we need to find numbers that multiply to get 0 and add. Oh, no, wait. Nah, okay. I'm going to do a different method. I'm going to add 3 to both sides. So I get 3 equals 4x squared. I'm going to then divide both sides by 4. So I get 3 over 4 equals x squared. I feel like I should be doing a better method than this, but meh. And then to get rid of a squared, all we do is take a square root of both sides. So I get square root of 3 over 4 equals x. But you say, but Mr. Forbes, aren't there meant to be 2 solutions? You're absolutely right. There does need to be 2 solutions. But when we do a square root, the square root actually has 2 solutions, right? Because it could be the positive or it could be the negative. Right? So for an example, I'm just going to show you, if I do the square root of 4, right, there's actually 2 solutions. So we should write positive, negative square root of 4, because the 2 solutions are, you could do 2 times 2 gets you 4, but then there's also the other one, which is negative 2 times negative 2. I feel like I overcomplicated that question. That's fine. So that's your solution there, positive or minus square root 3 over 4. Whoa, okay, yes. How do you know which x is bigger or smaller? Wasn't it 3x because 18x over 6? Oh, what did I do wrong? When am I we get 3x, but you've only written 3. Yeah, that's why I got confused. Thank you. Okay, should I show you guys how to correct when you make a mistake? I think this one's way too deep. You probably learned a concept there, though. You're absolutely right. That is what would happen. That's fine. We all make mistakes, especially me. And I can live with that just fine. Okay, let's start from the beginning again, eh? 18x minus 24x squared equals 0. I'm going to do it completely different now. I'm going to multiply both sides by... Oh, wait. I'm going to factor out an x straight away. I think that's what they really wanted us to do. Factor out an x. X 18 minus 24x equals 0. And I think they also wanted us to factor out a 6 as well. So it's going to become 6x 3 minus 8. Whoop, wait, what did I do wrong? No, that's 4. Okay, let's see if we can transform that into a 4. Oh, yeah, beautiful. Oh, yeah, that's a handsome 4. A very handsome 4. Minus 4x equals 0. Is that better? You guys happier with that one? Thank you for spotting my mistake. You are absolutely right. So this new method's actually way better, so probably good that I made a mistake. 6x equals 0 is one possible solution. And then over here, 3 minus 4x equals 0 is the other option that comes out. So here we get x equals 0 because 0 divided by 6 is 0. And then over here, I'm going to add 4x to both sides. And I get 3 equals 4x. Then I'm going to divide both sides by 4. And I get 3 over 4 equals x. Yeah. So someone asked the question, how do you know which one is smaller and which is bigger? It's a good question. I'm thinking on a number line. So on a number line for this one here, we've got 3 over 4 and 0. So on the number line, 0 would be there. And then 3 over 4 is larger than 0. So that one's going to be my x1, and that one's going to be my x2. So yeah, it's just where they sit on the number line. So Sorry, confusing you guys on that. How much faster do I need to move? Probably a little bit faster. Okay. Question 4. Let's find a good example from question 4. I should really look at these in advance, eh? Okay. I'm assuming you're not going to be doing B. 4B. 5x squared minus 25x minus 250. Surely you guys can see the pattern that they've snuck into this one. I'm going to actually see if you guys can spot it. Can anyone spot any pattern?
5.
Yeah, nice. Yeah, so we could actually get everything here and divide it by 5. So we get x squared minus 5x minus, oh, that's a tough one. 50 equals 0. Nice. And then here, two numbers that multiply to get negative 50 and add to get negative 5. Is that a 5 and a 10? And the negative has to be larger. So I can see 5 times 10 is 50. And one of them has to be negative, one of them has to be positive, and the negative is larger. So it's going to be x minus 10, x plus 5. You can go back to that other method I was doing, but as you factorize lots, and factorizing is really big in mathematics, you find that you get quite fast at noticing the pattern. Just more prone to making mistakes, I think. That's why you got to get good at checking your answers. Okay, let's have a look at question 5. What's a good example? Pick a random one. Why not? G. Ooh, these actually require you to learn a new technique. I think we may have already learned it. I think you learned it maybe in week 2. 10x squared plus 7x minus 12 equals 0. By the way, I haven't finished question 4 yet. I'm going to show you an even. So this one here, x equals 10. We didn't solve it, sorry. Well, I didn't solve it. X equals negative 5. That one's smaller. That's now solved. Sorry for that. I'll do my arrows so you guys can see that I'm doing the same technique. Okay, back to 5G. These ones here, I think you've already learned it. What I like to do, and every teacher has a different means of teaching this one. I drew like an arrow going up to this one and an arrow going out to that one. The reason I know to skip here is because 10, 7, and 12 are co-prime because I know that the number 7 is prime. So I know that you're not going to be able to factor out anything here because 7 is a prime number. So 10 times negative 12 is what we do. That's why I do these arrows. We're doing 10 times negative 12, so that's negative 120. And then what we do is we do our little t below that 120. And we find ways to multiply to get 120 that would add to get a positive 7. So that's going to be tricky. Okay, let's see. Maybe like a negative 13 and a 20. No, that's way too big. Could we do, I'm going to see if you guys have got some suggestions. Negative 120 and add to get 7. So we could start with some ridiculous ideas, maybe. No. I feel like 120's got like a 15 in it somewhere, doesn't it? If I do 15 times 8, I don't know how you guys are meant to think of that. Oh, nice. Yep, you're absolutely right, Annie. 15 and an 8. Yep. So we got a 15 and an 8. We'll multiply to get 120. What one of them do we want to be negative and what one do we want to be positive? Because we've got a positive 7 down here. So we actually want the 15 to be positive because it's larger than the 8. So we're going to make 8 a negative. So negative 8 times 15 is negative 120. Yeah, absolutely right, Petra. And then the positive outweighs the negative, so we get a positive 7. Perfect. So those are the numbers we want. And what we do with those numbers is we split up that 7 into those two numbers. So we're going to have a 15x, it doesn't matter what side you put those numbers on, by the way, and a minus 8x. See how we can split a 7 up into those two numbers quite easily? no problems. So then we just carry everything else down. So we've got our 10x squared plus, and over here we've got minus 12. So now that we're in the split up form, I think you guys should have already practiced this quite a bit, I think, in week 2. So I should speed through this a little bit more, but it is a hard concept and you may know a different method. So I want you to know this one. Okay, so what we do is we pretend that the first 2 numbers need something factorized out and the second 2 numbers need something factorized out. So let's factorize out what we can from the first 2 numbers. I can pull out a 5 and I can pull out an x. 5x times what is 10x squared? That's 2x. 5x times what equals 15x? That's 3. So 2x plus 3 in the brackets. I want you to remember that for this next one. What do we need to factorize out of these 2 so that 2x plus 3 would be left in the brackets? We're going to pull out a 4, but see how they're both negative? And we want the brackets to be positive, so we're going to pull out the negative. So it's going to be minus 4. And then minus 4 times what is 8x? That's 2x. And minus 4 times what is negative 12? That's positive 3. Aha! Look at that. Our brackets match up. That's perfect. That's exactly what we want. So when the brackets match up, that means we can do this weird split up thing that we've already got 5x times 2x plus 3, and we've got negative 4 times 2x plus 3. So we can just put those things in a bracket together, 5x minus 4, so that they're both multiplied by 2x plus 3. So now we've factorized that using this wacky method. And then from there, we just do our little split off. 5x plus minus 4 equals 0. People get really fast at these. They see, okay, so I'm going to move the 4 over to make a positive 4. And then I'm going to be dividing by 5. So that's x equals 4 over 5. And then they look at this one and they go 2x plus 3 equals 0. And they go, that's going to make a negative 3. And then it's going to be divided by 2. X equals negative 3 over 2. Which of those is smaller? That one's a negative number, so that's smaller. So I'm going to make that one x1. I'm going to make this one x2. Okay. Oh man, we got to pick up the pace. I got 20 minutes to get through like the majority of the exercises. Okay, exercise 17.03. Solve these quadratic equations by rearranging and then factorizing. Okay, this one here, we probably can skip through quite fast. 17.03. Let's pick a random one. 7. Has to be odd. So we got x squared equals 6x. The whole idea is that we want to get it in quadratic form first, so then we can factorize using one of those methods that we've been learning. So the x squared's already positive on the left-hand side, so I'm going to keep it on the left-hand side, and I'm going to write x squared, and I'm going to minus 6x from both sides. Minus 6x. And I mean, we could put a plus 0 on the end, but we don't really need to. So we've got x squared minus 6x. Because we don't have a c, we can just factor out an x, which makes these ones quite easy. So we just factor out an x minus 6. And then from there, really easy to solve. You get x equals 0. And then this one, you get x minus 6 equals 0, x equals 6. That one looks smaller to me, x1, that one's x2. Nice. Okay, let's skip ahead. Does that one look hard? None of these look hard. This one, 18. This is going to show you a concept which should help you solving the rest of them. Sometimes what they do is they give you the brackets so it looks like it's already been factorized and you go, yeah, all I need to do is solve what's in those brackets. But they've done a nasty to you guys. Don't fall for the trap. The nasty is that this is not 0. Sneaky, blimmin' sneaky. So it's annoying because you think you're all ready to go, but you're really not. You have to expand these brackets, then pull the 13 over, and then factorize again, which is kind of annoying. So let's do that. X squared, so it's a minus 7 and a plus 5, so we're going to get minus 2x, and then minus 35x equals 13. We're then going to minus 13 off both sides. X squared minus 2x minus 48 equals 0. Now we're in quadratic form. Perfect. 48, and we need to get a 2. 48, is that 8 times, wait, 8 times 6, I think? So it's going to be x minus 8, x plus 6 equals 0. Then you get x equals 8 or x equals negative 6. That one's smaller. Sorry, I have to rush a little bit. The part of the concept that actually is more important to you guys has already been done. Let's push on. Okay, 17.04. Okay, these ones here, it's much the same concept, except we're adding in this new idea that if we've got A times B times C equals 0, now we've got 3 options. That could be 0, or that could be 0, or that could be 0. So now, when we have these are not quadratics anymore, these are cubics. And cubics actually have 3 solutions. I'm going to show you a little quick visual diagram. So if we were drawing a cubic, cubics normally look like this. Whee, woo, like that. That's a positive cubic. And notice that there's 3 points on the line that intersect the x. So quartics or cubics are going to have up to 3 solutions, 3 real solutions. All right, that's a positive. I should probably show you what a negative one looks like. If I was negative, I would do this. That's a negative cubic. I think we look into that in the graphs internal, which we haven't done yet. When we're back at school, maybe. Okay. Oh, there's actually blimmin' quartics in there as well, is there? Ay. So sometimes it's, I'm gonna get a different color. Sometimes it's even more, and it goes, wee, wow. And then it goes, wee. Wait, am I doing one more? Yeah, I'm doing one more. So sometimes there's going to be 4 solutions, and that's called a quartic. So that's when you got x to the power 4. So that's x to the power 4. This one's an example of negative x cubed, and this one's an example of x cubed. All right, so that just means we've got more solutions. Anyway, you might be getting a bit bored. Let's have a look. Let's choose question. Oof, all of these are ugly. All right, I'm going to choose question 11. This one here, we've got x squared plus 9x plus, minus 22 and x minus 11. So it's already been partially factorized, ready to solve. This here is going to be easy to find a solution to. So we could do that right at the beginning. So one of the solutions is already going to be x equals 11. But this one here, it's not fully factorized, so we're not ready to do that. So we just need to factorize what's in these brackets. So we need to find a number that multiplies to get negative 22 and adds to get 9. 11 and 2, is that right? So we're going to get 11 times 2 is negative 22. Which one needs to be negative? The positive is outweighing, so that means we need to make the smaller one the negative. So that's going to become x plus 11 and x minus 2. That x minus 11 would carry on as well. All right, so now we've got 3 brackets here, and we just solve all of those. We've got x equals negative 11. Here we've got x equals 2. And then here we did that one before, x equals 11. So those are the 3 points where it crosses over. Which one's our smallest? That's our smallest. That's our next smallest. And then that's our largest. So there's 3 solutions to that one. So all you're doing is just factorizing it till you've got simple things. It's pretty much removing any x squareds. If there's an x squared, you're going to need to factorize it out. So this one here is a quartic. There's 4 x's involved. So x, 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 x. Yeah, but I think that's enough for you guys to be able to do that. I'm going to push on because I'm taking up your precious time. Okay, so this here, this is going to come up in your exams. These are word problems. They flippin' love rectangles. Oh, boy, do they love rectangles. Okay, these ones here, I can't really show you how to do all of them. I can just show you how I would solve one. So we'll start with 11. We got this cool picture. A home handyman has sufficient concreting materials to lay a total area of 9 meters squared. He intends to make oh, why did I choose this one that goes to the page? Come on. Rectangular L-shaped region with overall dimensions 6 meters, 4 meters, as shown in the diagram. The width of each arm is to be a uniform X meters. Oh man, it's all done for us. Express the area in terms of X using this information, hence form a blah, 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 solve it. Okay, these questions here, draw a picture. Even if they give you a picture, draw a picture, because drawing pictures is fun. So we've got this. That's 6, that's 4, that's X, and that's X. It's all about the area, and we know that the area overall needs to be, he had enough to do 9 meters squared. So it's going to be equal to that. Now, this picture is kind of hard to look at, but when I do this, we can now start thinking about areas, because we know that that's X, so we know that this is X as well, and we know that that's X. So this area of this little bit is X squared, right? We know that from the top to the bottom was 6, so therefore this we know is an X from here to here. So what's missing? The other bit here must be, or this bit from here to here must be 6 minus the X. And here, if the overall is 4, then, and we know that this bit is X to X, this one here is going to be 4 minus X. So now we've got the length of that. So we could find out all these areas. Man, there's got to be an easier way to do that. No, not really. Surely there's a cooler way to do that. Someone's going to think of a cooler way. This one, I've made it maybe overly complicated. So we've got an X squared here. So that's one part of my area. Then that's going to have added onto it. This one here is going to be 6 minus X times X, because the base is X and the height is 6 minus X. So it's going to be 6 minus X times X. So I'm just going to write it like this. X, 6 minus X. Here, we've got X is the height. So it's going to be X times 4 minus X, which is the base. If someone can find a better way to do this, I feel like I've done this a really dumb way. But sometimes you just got to go for it, you know? Okay, and then overall, has sufficient quantity to make, he intends to make a blah, blah, blah. Okay, so the overall area is 9. And they want us to find out what the heck X is. Someone puts in the comments a better way to do it. Anyone? So pretty much I split this shape up into 3 areas. I had this area here, this area here, and this area here. And I just used maths to find out what each area was equal to. So I know that X times X, which is the base and the height of this area, is X squared. So I wrote that down there. So that's the first box. This one here, the height is 6 minus X, and I found that out by taking that X away from it. I'm just going to double check the picture, see if I didn't screw it up. No, I didn't. So that's 6 minus X times X, and then this area is X, 4 minus X. So I've written all those areas out. That's the little one. This is the tall one. And this is the wide one's areas. These are all areas. And he told us that he can only do 9 meters squared of concreting. So that's the area of concrete. So now what we do is we'll just expand that out. So we get X squared plus 6X minus X squared plus 4X minus X squared equals 9. Oh, I'm getting a little bit worried. These cancel. We got a minus X and a positive X. That positive 6X and positive 4X together makes 10x. So we get 10x minus x squared equals 9. What do they want us to do? Express the area in terms of x using this information and hence form a quadratic equation. This is a quadratic equation because we've got an x squared in it. Let's rearrange it. What I'm going to do is I'm going to minus 9 off both sides. So we get 10x minus x squared minus 9 equals 0. From there, I want that to be positive, so I'm going to times everything by a negative 1. So I'm going to get minus 10x plus x squared plus 9 equals 0. From there, I'm going to rearrange into quadratic form. I'm not changing anything, I'm just changing the order that things appear in the expression. So from here, I just need to solve that. So I need two numbers that multiply to get 9 and add to get negative 10. If you're multiplying to get a positive and adding to get a negative, they're both going to have to be negative numbers. So we're going to have, it has to be big numbers. So it's going to have to be negative 10. Oh, no, whoa, what am I doing? Negative 9 times negative 1. Negative 9 times negative 1 is positive 9, and they add to get negative 10. Perfect. So we're going to have x minus 9 and x minus 1. I'm a little worried this isn't going to work. Let's solve that. X equals 9 is the first one, and x equals 1 is the second option. I feel like they're crazy. So there's actually two solutions to this equation now. So the question was, so we've found a quadratic equation, nice. Rearrange in terms to give the equation in the form and solve the equation. So x either equals 9 meters or x equals 1 meter. I want to see if that works. So I'm going to go back to the original question. So that would make, where the heck does this 9 come from? Did I do something wrong? Can anyone see an error here? Kyle, look for the problem. Because I feel like that's going to be funky, like way out. Because we decided that the area of this was x squared, so then that would have to be, if we were following this one, that would have to be 49, and then we'd have negative 3 times 9, which would make that negative 3 times 9 is negative 27, and then this one would be 4 minus 9 is negative 5, negative 5 times 9 is negative 45, and what would make, that would make the overall area way off. What did I do wrong? 5 times 9. That one would be, oh wait, no, that's not 49. That's 81. So if we were using that, let's see if this works. Let's see if the area adds up. 81 plus negative 27 plus negative 45. What's that? Ugh. That makes 72. So 81 minus 72 equals what? Oh, mate, that's tough. That's tough stuff. 9 meters squared. Ugh, that is so ugly. So one of the solutions, 10x plus x squared. That's a good suggestion, but because look at this, we've got, see how that x times negative x makes that a negative x squared there. No, I've looked at it, and this is actually right, sadly. The two solutions are x is 9 meters. That we just confirmed that that does work because we added up the areas from our prior thing, and sadly it came out as 9 meters squared, which is right. Let's have a look at, but the problem is, can you have a negative area? Can you have negative area? Question. Can you have negative area? No, you can't. So this solution, we can say, nah, it can't be 9 meters. So we can say you can't have negative area, so therefore x cannot equal 9 meters. All right, let's check if the other one works. Let's have a look at it. So we're going back to I'm going to draw this shape again. So let's test with x equals 1 meter, and we'll see if it works. X equals 1 meter. And so we had x, this area was x squared. So 1 times 1 is 1. This area was 6 minus x times x. So 6 minus 1 is 5 times 1 is 5. So that makes that area 5 meters squared. And then this final one was 4 minus x times x. 4 minus 1 is 3 times 1 is 3. 3 meters squared. Now, does that work? Do these add up to 9 meters squared? Let's test it. 5 plus 1 plus 3 equals 9 meters squared. Yes. And look at that. All positive areas. So x must equal 1 meter. That's the only solution because we can't have negative area. Thank you for all of your affirming no's in the chat. Very nice to hear. Okay. Oh, I've got 2 minutes to somehow finish everything else. So these questions here, I could spend all day showing you how to solve those, but you really have to have a go yourself. Okay. The next one's completing the square. Do you guys want me to push on? Like, we've got a lot more stuff to cover. I mean, I could just do another lesson at another time. Or I can make a video, or I could do something else. Completing the square, to be honest, this is a level 3 thing, but I always teach my level 2s. I always teach my level 2s how to complete the square because it's beautiful. Oh, it's so hard though. This is going to take like a 20-minute explanation. See if I can do it in 10 minutes. Completing the square, 17.06. I'm pretty sure she asked you to do that. So, yeah. Oh, wait, 17.07. Yeah, we've got 2 more sections to go. Make vids. Nia reckons make vids. Yeah, I'm going to skip that. I'm going to do a video on completing the square because it's beautiful. Quadratic formula, you guys will definitely use. Quadratic formula, you get it on your formula sheet. So you're going to be given this information and that information on your formula sheet. So it's so easy to do. So we're skipping 17.06. We're just going to go to 17.07. I'll make a video on completing the square and I'll chuck it up on the classroom later on. Using the quadratic formula, I got my class to memorize this. X equals negative b plus or minus square root b squared minus 4ac divided by 2a. Beautiful. Oh, my dog thought that I was talking to him. No, I'm not talking to you, Finn. All right. Beautiful song. If you like it, yeah, thanks. If you like singing, straight bars, sir. Okay, you ready for the next one? X is equal to negative b plus or minus the square root b squared minus 4ac all over 2a. That's just because the quadratic formula is useful. It's super useful in maths. Make a YouTube channel. Yeah, hi, thanks. Wow, that worked perfectly. It did, I know. Pop Goes the Weasel is really useful for quadratic formulas. So this formula here, use it to solve everything. Pretty much, if you get something in the form ax squared plus bx plus c equals 0, you can just whack it into this quadratic formula. You don't even need to know how to factorize anymore. This thing is overpowered. It's like a calculator, but you don't even need a calculator. Super duper handy. The reason you get 2 solutions is because there's this plus or minus here. And also, that b squared minus 4ac is a determinant, and that's useful for all sorts of things as well. So this formula is like amazing. So let's have a look at question 11. 3x squared plus 5x plus 1 equals 0. Nice, it's already in quadratic form. We know that a equals 3. We know that b equals 5, and we know that c equals 1. So it's all ready to go. Perfect. So we just put it into our formula. X is equal to negative b. Look at that, beautiful. Plus or minus the square root. And then b squared, so we got 5 squared minus 4, and then I put these in brackets, by the way. A, C, beautiful. All over 2A. Nice. Look at that. Don't even need to check the formula sheet, just memorize the song. Too easy. Oh, my friend's playing Project Cars too. How exciting. Okay, so let's just do a little bit of unpacking here. Generally, the unpacking happens inside the determinant, this little thing inside the square root. Minus B. Okay, so inside, let's see if we can unpack that. So we got 25 minus 4 times 3 is 12, and that's a 1. Boring. All over 2. X equals negative 5 plus or minus square root 13. Did I make a mistake? Why are they giving us such ugly things? 13's a prime. 13 is prime, and it's not a square number. What the heck are they doing to us? It's disgusting. You know what? I can't be bothered dealing with this right now. X1 equals negative 5 minus the square root of 13 over 2. That's the first solution. See, I'm just looking at the minus side. The minus side is always smaller. And x2 equals negative 5 plus the square root of 13 over 2. Why am I leaving it like that? Because 13 is a flippin' ugly, ugly square root. It's disgusting. What are they doing to us? It's 2, 3. Did I do something wrong? It's 2, 3. B squared minus 4ac. It's 2, 3. What does that mean? What did I do wrong? 2 times a. Okay, I can see that you guys are trying to help me with something. You put 1 instead of 3 for 2a. Put 1 instead of... Yes. Put 1 instead of... Wait, what the heck? What did I do wrong? You put b squared minus 4ac. Oh, whoopsies. Yeah, you're right. Sorry. That should be a, yeah. Thank you. But it doesn't change much. It doesn't make anything any prettier. That's a 3. Therefore, that becomes a 6. I do this all the time in my maths. Don't worry. That's a 6 as well. And that's a 6. Doesn't change anything. Except those. I'm still not bothered about doing flipping this square root 13 because it's ugly as. Let's see how ugly it is. Let's see how ugly you are. Show yourself. Square root of 13. Disgusting. So we could sit here all day. I honestly wouldn't do, just because the question's so flippin' ugly, I wouldn't do anything more than this personally, even in an exam, out of pure disgust for their horrible question writing, because it'd be 3.606 over 6, and then that would go negative 8.606 over 6. Like this is such an ugly question. Negative, what is it? 8.606 over 6. Ugh, that's just despicable. No one wants to see that number. 3, 4. Disgusting. Disgusting. How long is it? Yeah. Okay. Yeah, absolutely right. I'm gonna have to go. There are still 2 more sections. They want us to do 13. I'm gonna make videos on them because I've made you guys listen for way too long. So that's all for now. Unless you guys have any questions, I am going to stop the recording. That's all good. Hopefully I made that clear. Yeah. Stop recording. I have to do this.
Yeah. Thank you, Mr.